All right, guys, this is section, we're just finishing up. This is just part B. So this is section, what is this? 3.4, part 2, and this is just going to be finishing up part 2, so B. Remember, it's just easier to do it in smaller pieces on YouTube. Okay. All right, so this is part B. So part A, we did 1 through 5. Here's the notes, literally 4 and 5 at least. And now we just have to do 6 through 9. Okay, so part B, we're going to finish up 6 through 9. Okay, remember, this is really only one part, but I did break it up into 2 videos, and it is going to cover April 6th and 8th. And then the 10th is Good Friday, so there is actually no class. Oh dear, you can't even see. Goodness gracious. Okay, so this between A and B, I'm going to have A and B cover April 6th and April 8th, and then April 10th is Good Friday, so there's no class. And so there'll be one homework assignment. Part 2, between A and B, there's one homework assignment for these 2 days, and then we will have finished the whole week. Okay. All right, so let's take a look at 6 here. If air resistance is ignored, a projectile such as a cannonball follows a parabolic path. Parabolic is just a fancy way to say parabola. Okay, we know it's a parabola because we got the squared in it. Okay, notice the squared is down here. It is what it is, but as long as it has a squared, then we're talking about a parabola. Okay, suppose a cannonball fired from the origin follows this graph. Okay, where x and y, now both of these x and y are measured in feet. Okay, so we know nothing about time, and that's okay. Notice it says it's fired from the origin. Okay, so this cannonball is going to go up, and then it's going to go down. So we can talk about its height this way, and then we can talk about its distance this way. Both are in feet, so there's nothing with time, and that's okay. That doesn't always have to be about time. X is the distance, how far it goes, and y is the height, how high up it goes. Okay, so I might change this. Y is the height, so I'm going to do h equals, and x is the distance, how far it has gone this way, left to right. So d minus 0.0005, and then d squared. Okay. All right, how far downrange will the cannonball hit the ground? So we want to know how far. How far? So that is distance. So we're looking for distance. We're looking for distance. Okay, here's where we have to think again because there's no other numbers. What do we know about its height if it's on the ground? What about its height if it's on the ground? Its height is 0. So ground height is 0. So we're going to put a 0 in for h. 0 equals d minus 0.0005 d squared. Okay. And this, you could do quadratic formula. Your c would be 0. If you like that method, go for it. We could actually factor, though. What do these two have in common? We could take out a d. Now, if I take out a d, what am I left with? Remember, you have to divide each one of these by d. You have to divide each one by d. Well, what is d divided by d? D divided by d is 1. You must write that 1 there. And then here, 1d cancels with 1d. And so you've got minus 0.0005 and then d. Okay. And so then either this equals d, or I'm sorry, either this equals 0, d equals 0, or 1 minus 0.0005, d equals 0. Okay, if you're multiplying and your answer is 0, then one of them. There's kind of like a parenthesis here, even though it's just d, so this equals 0, or this equals 0. Okay. Now, The height is 0 when the distance is 0. Height is 0 when the distance is 0. What's that all about? Well, that's the beginning of the problem. So that in no way, shape, or form tells me how far downrange the cannonball hit the ground. But it is a true statement. When the height is 0, my distance is also 0, because that's the start of the problem. So I'm really interested in this guy. So we got to solve this for D. Okay, so we're going to subtract 1. Watch all your negatives. You've got negative 0.0005 D equals negative 1. This is multiplication, so you divide by negative 0.0005. I could have left a little bit more room, I think, on this note sheet. Okay, but we're okay. So these cancel, and so D equals, just grab your calculator. What is negative 1 divided by negative 0.0005? And we get 2,000. 2,000 feet. Okay, 2,000 feet. So it had a height of 0 at 0, the start of the problem. So this isn't wrong. It just is not helping me answer the question. And then it hit the ground at a distance of 2,000 feet. Okay. How far downrange? You tell me, is this height or distance? How far downrange? That is distance. How far downrange is distance? Will the cannonball reach its maximum height? When you see the word maximum or minimum, because remember, parabola can go 2 different ways. What are you thinking? Tell me what you're thinking. As soon as you see the word maximum, you are thinking vertex. Vertex, we're looking for this high point. Okay, maximum or minimum is vertex. As soon as you see that, you're thinking vertex. And the only thing you can find right away is negative b over 2a. And that finds you your x value, which in this problem is the d, which is perfect because that's what I'm looking for, distance. Okay, so here I just simply plug it in. The only thing when I do vertex, the only thing I can at least find first is negative b over 2a, which gives me my x, which in this problem is the same as d, and that's distance. So that's perfect. Downrange is distance. Negative b over 2a is x, which is also correlate to distance. All right, so now here's where we had to be careful, though. Let's see. I need more room. Who wrote this? Who wrote this note sheet? Okay, this is very important. Let's rewrite. Let me rewrite this. I like the H and D, and this doesn't take very long. So let me rewrite it. Where should I rewrite it? H equals D minus 0.0005 D squared. Okay. What's wrong with this guy? It's not in the correct order. It has to have the x squared or the d squared first. So H equals, and this sign has to come with negative 0.0005 d squared, and then this d is positive, so plus d. That is important. So not only did I change them to d's and h's, but especially for this problem, factoring it didn't matter so much, but especially for this problem, I got to have my squared first, and then the d, and then if necessary, then the number by itself. So this one took a lot of rewriting. Okay, so now what is b? I need a third color here. B is the number in front of the x or in front of the d. What number is right here? The number in front of b is 1. Okay, so this should actually be negative 1, because I have to change the sign, over 2 times a. Now what is a? A is the number in front of the x squared or the d squared. So negative 0.0005. Okay. Okay, so now grab your calculator. This turns out to be an interesting answer. So we want negative 1 divided by parenthesis 2 times negative 0.0005. And that gives me 1,000. So, how far downrange? How far? So that's D. So I'm okay with that answer. And this turns out to be exactly 1,000 feet. Okay. So this was part A. Okay. And now this is part B. I'm gonna have to make a note to make more room for next year. Okay. Now, what is the maximum height? Well, as soon as it says maximum, I'm thinking vertex. And I just found the distance. Height goes with y. How do I find the maximum height? How do I find the y vertex? Height is y, maximum is vertex. How do I find the y coordinate of the vertex? I simply plug it in. Y equals, or H equals, which is y equals. I plug it in. And here I can go to any formula I like, whichever one I want to. Maybe we'll go back to the, should we go back to this one? D, which is 1,000. 1,000 minus 0.0005, and then I had to do 1,000 squared. Okay. So that gets a little messy. Let's just plug it in. 1,000 minus 0.0005 times 1,000 squared. And that actually gives me an answer of 500. So this is, maybe I'll do it in red. Well, this is this feet? Okay. So this, let's draw it one more time. Here's my cannonball. Where it hit the ground was a distance of 2,000. That was A. So this distance here is 2,000. Okay. This point here, how far down does it happen? It happens at 1,000. And how high up is that? 500. Okay. The 1,000 is how far over, and the 500 tells us how high it is. Okay. All right. Try that one. That one's a little bit harder. We didn't have a ton of room. All right. I think the last three aren't too bad. All right. Let's make sure we can see it. Okay. Cars depreciate in value pretty quickly, right? As soon as you drive it off the lot, your car's not as worth as much as you paid for it. You can drive a half a mile, and if you turn it back in, they won't give you the same price. All right, but what happens at some point, certain cars, at least certain cars, become antiques, right? And those prices start going up again. So the price of the car goes down, but at some point, if it's a nice enough car, fancy enough car, the price actually goes up, at least a little, okay? So there's some parabolic or parabola shape to it. Okay, especially it's not linear, it's not V-shaped. As soon as you drive it off, it goes down quite a bit, and then it kind of peaks off, and then it actually starts to go up. Okay, let the value of a 1972 Mercury comet be modeled by this. Okay, T is the number of years since 1972. Okay, so how many years will it go down? And then at some point it'll go up. And then V is the actual value. How much is this car actually worth? Okay. How many years since 1972 was the car's lowest value? So we're looking for years. How many years? So we're looking for T. And we want the lowest value. What are you thinking in your head when you see maximum or minimum? Lowest goes with minimum, and that is vertex. The vertex. The vertex is x comma y, or in this problem, it is t comma v. T, comma v. And the question says how many years, so we're looking for x. For the vertex, though, what's the only thing I can find, or what do I have to find first? I have to find time first, but I think that'll answer my question. Okay, so let's do, how do I find vertex? The x-coordinate, which is the t-coordinate, negative b over 2a. Okay, and everything looks good. This is set up really nice. Let's see, maybe I'll slide it down. Maybe I'll just rewrite this. V equals 18.75 t squared minus, I'm just copying it, 450t plus 3,200. And I want the number in front of the x squared or the t squared is a, and the number, make sure you take the sign with, is b. Okay. Max or min, I'm thinking vertex. This one happens to be minimum, but that's okay. Vertex is negative b over 2a. So opposite, or negative b, or the opposite of b, so it's actually going to be 450. Negative b is the same thing as the opposite of b, so it's actually positive. And then 2 times a, which is 18.75. Okay. Type that into your calculator, 18.75 times 2. So this is 450 over 37.5. Divide that out. 450 divided by 37.5 gives me something, oh, it's exactly actually 12. Okay, what is the 12? The 12 is my x or t, and t is the number of years since 1972. So how many years since 1972? 12 years. Okay. Then what year was that? What year was that? It has nothing to do with y, because y is a value. It has nothing to do with y. I just want to know 12 years after 1972. They just want to make sure you understand what this 12 years is. This 12 years is 12 years after 1972. So 1972 plus 12 years after that gives me 1984. Okay. That's all they were asking for there. So both of these involved x or t. Both of them were time. 12 years after 1972, and then what year is that? We just add that to 1972. All right, let's try this one. The profit function telling Gino how much money he will net, okay, how much money he'll get, right, for producing and selling X specialty umbrellas is given by this. So his profit, this tells us how much money he's going to make. This is his profit. X is the number of umbrellas. X is how many umbrellas. Okay, X is how many umbrellas. How many? Okay. How many does he have to sell to earn the greatest possible profit? Okay. So how many? What represents how many is X. Okay, that's how many he has to sell. Greatest profit. How many does he have to sell for the greatest profit? What are you thinking greatest is like maximum? As soon as you think that, as soon as you see that, you're thinking vertex. Okay, and how many? It wants X. When you do vertex, though, the first thing you have to find no matter what is X. But in this problem, I think that's going to answer the question. How many? X is how many. Vertex X is negative b, or opposite of b, over 2a. Okay. This is a. The number in front of the x squared is a. The number in front of the x is b. The number by itself is c, with no x. Opposite of b. The opposite of b. So negative 8.15 over 2 times, just take your time, negative and then 0.20, 405. Okay. And then it's just a matter of typing that in. If you want to type this in first, 2 times negative 0.00405 So this is negative 8.15, and this is negative 0.0081. Make sure you guys can see. Yeah, it looks good. All right, so negative 8.15 divided by negative 0.0081, and that gives me, this is how many? So I think it's, you round to the nearest whole number, right? Because you can't have a decimal umbrella. So I got 1,006, what did I get? 0.17. So that would round to 1,006. Okay. And this is the number of umbrellas, 1,006 umbrellas. Okay. That'll give us his maximum profit if he sells 1,006 umbrellas. All right, let's try one more, last one. How are we doing on time? Okay, we're good on time. All right, Chip ran through a maze in less than a minute the first time he tried. Okay, his times got better for a while with each new try, right? As the more you know a course, the better you're going to be. But then his times got worse. Okay, it took longer. Why would it take longer? Because now he's getting tired. Okay, he's not taking a break. So maybe the first couple times, the first 3-4 times, he's cruising. He knows, every time he knows the maze, he's going to go faster. But at some point, even though his brain knows exactly where to go, his body starts to slow down, right? We're not talking about days. We're talking about one right after the other. So even if he knows exactly where to go, his body's going to start to get tired, okay? So, oh dear. There goes the lights one last time. Let's see if I can turn it on. But like I said, maybe I'll just leave, oh, I was going to say maybe I'll leave it off. All right, so his times start to get better, which is actually smaller, right? His times start to get smaller and smaller. That's better, right? Who's a runner? You want a smaller time each time. But at some point, even though he knows the race, he's getting tired, and so then his times are going to go up. Okay. All right, so the amount of time, now let's be careful here. The amount of time Chip took to run through the maze can be modeled by this, where X is the number try he's on. Okay, so this is one time, guys, where time is actually over here. Try number 1 is going to spit out a time. Try number 2 is going to spit out a time. Try number 3 is going to spit out a time. All right, so time is actually Y. What number try? What number try? What is that? What number try is X? Okay, was his best time. Now this one we really have to think because it maybe doesn't stick out right away. But his best time would be the smallest. Best time would be the smallest, which is a minimum, which is the vertex. Okay, best time would be the very absolute smallest. Smallest is the same thing as minimum. When we're talking about minimum, we're talking about the vertex. So we're right back at it. Vertex, the only thing we can find first anyways is X. Opposite of B over 2A. Okay, now just be careful. This first one is A, and the second one is B, and this last one, if we need it, is C, but we don't actually need it. So the opposite of B, make sure you take the sign with, so that's positive 9. 2 times A, and A is 0.5. Okay, so 2 times 0.5 is actually 1. So it is actually 9. He's got a pretty good endurance because his fastest time, his best time, is on, what does that 9 represent? That 9 represents the 9th try. I found I found X, which is the number, try number, or what number he's on. So the 9th try, he did his absolute best. Okay. What was that best time? What was that best time? Well, I want this guy. I want T, which is Y. I'm still at the vertex because I'm still at that minimum value. So how do I find time at that minimum value? I plug in 9 because that was X. I plug in 9. So 0.5 times 9 squared minus 9 times 9, running out of room, and then plus 48.5. So I just plug in 9. 9 is x. I plug in 9 for x. 0.5 times 9 squared minus 9 times 9, and then I need to fit in there plus the 48.5. Okay, and then just grab your calculator, type that in, and that should, we can actually type that whole thing in depending on what type of calculator. 0.5 parenthesis 9 squared minus 9 times 9 plus 48.5. Okay, and that gives me 8. What does that 8 represent? 8 seconds. That's pretty quick. It's maybe a fairly small maze, but on the 9th try, he did 8 seconds. And that's his absolute minimum. Everything else, every other time, is bigger than 8 seconds. Okay. All right, give it a try. You want to do, where are we at? Can we see the bottom? You want to do 3.4, part 2. Okay, homework. Remember, there's an A and B to this. Can you see? Yep. There's an A and B, but there's only one homework assignment. So you're looking for homework assignment part 2. Okay, 2 videos, 1 note sheet, 1 homework. All right, go get them.